now going to look at p-charts for varying sample size. Now, our discussion earlier of the p-charts assumed that samples of size n could be drawn repeatedly from the process to be controlled, and that the number of defective units in each of these equal size samples could be counted for control purposes. But in many situations, the samples of the same size may not be available each time you want to take a sample. For example, if you're looking at products that are produced during a day, and you're counting the number of defective products that occur during one day, then every day you're going to have a different sample size. So in this case, then, we need to have a chart that can accommodate varying sample sizes. And so we call this a p-chart with varying sample sizes. And the good news is that there's no big difference. You're still counting the number of defects or defectives in a sample size, and you are then going to be plotting that number. But there's an important change. We have to look at how we calculate our 3 sigma control limits. If you remember, the control limits, they depended on the sample size. And so if you have varying sample size, then the control limits for example, your ith sample will depend on the size of your ith sample. And this means, is what's important, is that these control limits will vary. You won't have one set control limit then for your entire process. It'll depend on the sample size. Now, this is quite time-consuming if you're not using a computer, so one way of handling this is to use an average value, like an n bar. And then this can be used to obtain constant control lines. And this is valid if there's not a lot of variation in your sample size. It's not scientifically validated here, but it's considered adequate for practical purposes. For example, if you have less than 25% variation from the largest and the smallest, of the largest and the smallest samples from the average sample. So, but now we're going to look at an example where we actually do calculate the control limits depending on the actual sample that's taken that day. And here we have, again, daily production of castings in a foundry. And so we have, for example, day 1, going down here, continuing down to day 35. So every day, the number of castings found each day with a burn-in defect here were counted. So day 1 had 26 castings, 1 defect was found, so 1/26 gave us our p-value. Day 2, we had 54 burn-in defects over 107. So we had a p of 54/75. For day 2 was 0.305. So overall, we got an average p-value equal to 0.436. So of course, we need this. This is going to be, like before, our center line. Now what we want to do, though, is construct a p-chart for varying sample size for all of these 35 days. Now just to note, because we'll use these as an example, on day 17, we have a sample size of 158 and a pi of 0.658. And on day 35, we have a sample size of 151 and a p of 0.556. So let's go through these 2 examples. And the first thing was the p bar value was equal to 0.436. This means that 1 minus p bar is equal to 0.564. And so the upper control limit then for day 17 is going to be equal to 0.436 plus 3 times the square root of 0.436, so p bar times 1 minus p bar, which is 0.564, divided by the n for the day, which is 158. And this gives us then a UCL of 0.554. Do the same thing for the lower control limit, the LCL, and you get 0.318. Now, if you remember, and I won't go back because I'm worried about my control of my screen here, the P value for day 17 was equal to 0.658. So are we in control on day 17? The answer is no, we are out of control on day 17. This P, 0.658, is larger than our upper control limit. Now we do the same thing here for day 35, and we would end up, if I do it very fast, 0.436 plus 3 times 0.436 times 0.564 divided by 151, this time 151, we would get an upper control limit for day 35 of 0.557 and a lower control limit for day 35 equal to 0.315. And the P for day 35, if you remember, was 0.556, which lies just inside those two control limits. So that one is in control. Now, what is this going to look like? Here is our control chart for the P chart with varying sample size. And what do you notice? We have our P center line is P bar, but the control limits. Now this is done by Minitab. So Minitab gives you these kind of dotted lines here, these sort of average lines. We're not looking at that. We're looking at these step control limits. The control limits change. They make little steps depending on your sample size. So every sample has a different control limit. And remember we looked at sample 17? Well, here we were just out of control. We were out of control. So our control limits for day 17, out of control. Day 35, we had these control limits. And you remember our point was just in control there, just in control for day 35. So what we're seeing overall is that we definitely have some points here and here that are out of control. And then there's a period in here where we have points in control. So then we would continue with this analysis the way we would with the way we learned in the previous sections. Now, just to show you, this is obviously a little harder to read. You can, as we said, use an average value, N bar, as long as there's not a lot of variation in your sample size. And here the N bar was 161. So if you calculated these out, so again, 0.436 plus 3 times the square root of 0.436 times 0.564 divided by 161, we get here 0.553, and for the LCL, 0.319. Actually, I should maybe scratch out the I there because this is for the average N bar. So now, remember, the P for 17 was equal to 0.658, and the P for day 35, sample 35, was 0.556. What we see here, so this was 0.553. Can you read that? 0.553. Here was 0.319. So yeah, again, we're still out of control. And what we see for P35, we were borderline before, and now with these control limits, we're also out of control. So you can see that you're depending on how you calculate these control limits, your accuracy will be a little different. But in both cases, when we were borderline and here we're out of control, it's still giving you information you can use in your production, assuming you have varying sample sizes.